sugar, spice, and everything nice. These were the ingredients chosen to create the perfect little girl. But Professor Utonium accidentally added an extra ingredient to the concoction, Chemical X. Thus, the Powerpuff Girls were born! Using their ultra superpowers, Blossom, Bubbles, and Buttercup have dedicated their lives to fighting crime and the forces of evil!
Hello mga Ka-Blocks! And we are the group number 2. And for today's experiment, we're going to do experiment number 12, which is the breaking of our cylinder concrete specimen after 28 days. So let's do it!
Let's do this!
So the materials for today's experiment are the vernier caliper, the bearing blocks, the spacers, the load indicator, and the compression testing machine.
So now it's 3 days before the experiment of breaking of our concrete cylinder samples, and we will now take it out of our curing area. Wait, may namatay yung isda ko yun. Diretso, pe. Before we conduct our experiment, we will first, of course, need to take our concrete cylinder samples into the lab. Let's go.
Okay ka, Pati Dayan? After measuring our concrete cylinder samples, we will now put the bearing blocks onto our samples before conducting the compression experiment.
will now conduct the compression test of the cylinder.
Second sample. Anong din sa? Bakit? Last mo na.
In our concrete cylinder testing, each specimen displayed unique fracture patterns. Sample 1 with a cross-sectional area of 18,385.39 mm squared endured the highest load of 512,000 newtons and had a compressive strength of 27.8 megapascals. With a type 3 and 5 fracture, it fractured with vertical cracks at both ends and a side fracture at the top, lasting the longest at 86 seconds. Sample 2 with a cross-sectional area of 18,650.70 mm squared sustained a load of 484,900 newtons and had a compressive strength of 28 megapascals. It fractured diagonally and had a side fracture at the top, breaking in 50 seconds, the quickest of the three. Sample 3 with a cross-sectional area of 19,137.96 mm squared supported a load of 460,600 newtons and had a compressive strength of 24.1 megapascals. Despite its larger area, it had the weakest compressive strength. However, it provided the most accurate measurement with only 1.23% error from the machine's reading. Having a type 5 fracture only, it cracked at both ends for 57 seconds. In conclusion, this experiment assesses the compressive strength of concrete cylinders using a calibrated compression testing machine to meet ASTM C39 and DPWH's Blue Book standards. The objective was to achieve a Class A concrete with a minimum compressive strength of 20.7 megapascals for a 150 mm by 300 mm specimen after 28 days of curing as per DPWH's Blue Book section 405.4.1. However, due to time constraints, curing extended to about 46 days. Despite this, all samples passed both ASTM C39 and DPWH Blue Book standards. The first sample achieved 27.8 megapascals, the second having 26 megapascals, and the last sample with 24.1 megapascals. ASTM C39 allows a compressive strength range of 15 to 55 megapascals for such specimens, while DPWH mandates a minimum of 20.7 megapascals. Observing this, all samples met these criteria, therefore passing the standards.